Now let's look at this question on geometrical optics. When ultrasound passes from water to muscle, it has an increase of 7.0% in its speed of propagation. If the angle of incidence at the interface between water and muscle is 15.0 degrees, that's 15 degrees. So we are asked to calculate the angle of refraction. Now here is a hint. Represent the speed by c and 1.07 c. All right, so this is how to calculate this question. All right, so first thing first, we need to write down the given values. So we're given the speed of propagation in water, and that's c. Okay, we are also given speed of propagation in muscle, that is 1.07 c. Now it is 1.07 c because it increased by 7.0%, when it passes from water to muscle. So that means if we take the speed of propagation in water to be 100 degrees Celsius, 100%, okay, then it means as the ultrasound passes from water to muscle, then and it will have its speed of propagation increased by 7%. So that means we are going to add 7% to 100% multiplied by the speed of propagation. And we know that 107% is same thing as 107 over 100. So, and that's what we have here as 1.07 times speed of propagation. Okay, also we are given angle of incidence. Angle of incidence is also given. That's the angle of incidence between water and muscle is given to be 15 degrees. Then also, now we need to find the angle of what? Refraction. So to calculate the angle of refraction, so we're going to use the Snell's law. Okay, using the Snell's law, we know that Snell's law states that, okay, using the Snell's law, okay, we know that Snell's law states that the ratio of the sine of angle of incidence to the sine of angle of refraction is proportional to a constant for the light of a given color and for a given pair of material media. So in this case, of course, we can use that, but it can also be stated as the ratio of the sine of angle of incidence to the sine of angle of refraction is proportional to the reciprocal of absolute index of refraction. Now, when we say absolute index of refraction, that is the index of refraction in one material medium with respect to another. So the two media in this case are water and muscle. So the reciprocal of refractive index in water with respect to refractive index in muscle. So we can write this to be sine of angle of incidence divided by sine of angle of refraction equals to the reciprocal of index of refraction in water and index of refraction in muscle. Now this becomes sine of angle of incidence and then divided by sine of angle of refraction. That will be index of refraction in muscle divided by index of refraction in water. Now looking at what we have here, the equation we have in this case, now we cannot use this to solve this problem. Okay, that is because now we have ratio of the refractive index of the first medium to the what? To the second medium equals to the ratio of sine of angle of incidence to the sine of angle of refraction. So what we need is the equation, connecting this rate, the ratio of sine of angle of incidence to the sine of angle of refraction with the speed of propagation. So now what is now the relationship between speed of propagation and index of refraction? So the mathematical analogy for the relationship between speed of propagation and index of refraction is that speed of propagation is inversely proportional to the index of refraction of a material medium. So if I write C1 over C2 equals to N2 over N1. Now, because the first medium is water, so that means this will be CW. And because the second medium is muscle, so this will be CM, all right, subscript N. Then because the second medium is muscle, so this will be N subscript what? M. And because the first medium is water, then this will be what? N subscript what? W. So, and we have here that sine of angle of incidence divided by sine of angle of refraction is equals to this over this. And that's what we have here. And it equals to the ratio of the speed of propagation in water to the speed of propagation in muscle. So we are going to put this, we're going to replace this with this in this equation. So we have sine of angle of incidence divided by sine of angle of refraction equals to speed of propagation in water, then speed of propagation in muscle. Now, speed of propagation in water is c. Angle of incidence is 15. So this will be sine 15 degrees divided by sine angle of refraction equals to c. Then in muscle, we have that to be 1.07 c. So 1.07 c. So c cancels c. All right, so we'll be left with, so this will multiply this so that 1.07 multiplied by sine 15 degrees will be equals to sine of angle of refraction. So that sine of angle of refraction will be equals to 1.07 multiplied by sine 15 degrees. That'll be 0.2769. 0.2769. Now, the angle of refraction will be the inverse sine of 0.2769. So let's look for the inverse sine. Okay, the inverse sine of 0.2769. That will be 16.07. So angle of refraction is 16.07. So this will be approximately 16.0 degrees. And this is the word angle of refraction when ultrasound passes from water to muscle. Yes, ultrasound. When we say ultrasound, ultrasound is when we have any sound wave, okay, with a frequency above 20,000 hertz. That is a sound wave or any sound wave, okay, with a frequency greater than 20 kilohertz is defined to be what? Ultrasound. And when we talk about ultrasound, ultrasound has a wide range of applications, okay, because it can be generated at a very high frequency. All right, so the answer to the question is that the angle of refraction is equals to what? 16 degrees when ultrasound, okay, passes from water to what? Muscle. Because the frequency, because of the high frequency of vibration of ultrasound, okay, they can be transmitted into any tissue that is in contact with it. Because ultrasound can be used, like I said, it has a wide range of application. One of its application is medical therapy, then also medical diagnostics. Okay, like when used for imaging, for example, ultrasonic waves are usually emitted from a crystal known as a transducer, which exhibits what we call piezoelectric effect. Okay, and when we say piezoelectric effect, that is when we have the expansion and contraction of a substance. Expansion and contraction of a substance when a potential difference or a voltage is passed across the substance, okay? And that will bring about vibration of the world, of the crystal. The noblest pleasure is the joy of understanding. Bye-bye.